Hello everybody. Okay, so we have the next subtopic for chapter 7, geometry coordinates. So the next subtopic that we have is a parallel and perpendicular line. Okay, so before this we have the formula for line segment, right? So I hope you okay and understand. So we just add another information, okay, to all you have learned before. Okay, so first thing in this subtopic you have to know the meaning of parallel line and also the perpendicular line. Okay, what is meant by parallel line and what is meant by perpendicular line. Okay, so we see here. So if I have two lines, okay, before this previously I said a line is a very long, it can be very long, okay, and then we pick 2 points on it and we label it AB and it become the line segment. So if the two lines, okay, intersect, okay, the two lines they have a point where they touches or they cross, okay, we call it intersecting line. Okay, let's say they touch, but they touch at a specific angle, okay, so it is a perpendicular line, okay, specific angle which is 90 degrees. So you see this, okay, perpendicular line means the two lines touches at a specific angle. This one intersecting line, they can cross at any angle, so that why we cannot do anything lah. Okay, but if it's a perpendicular line, this is a special case. Or if the two lines never touch, okay, no matter how long we draw, okay, and it never met, then we will say this is a parallel line. Okay, so what happen when you have perpendicular and parallel line? Okay, so first thing is we look at the gradient. Okay, so when we talk about parallel and parallel line or perpendicular line, so the first thing, or any line, okay, the first thing that you must know is all the line will have a gradient. Okay, a gradient. So what is gradient? So if we take this example, okay, over here, okay, this is a line, yeah, L. Okay, this is a very long line. Okay, the L is can be very long line. Okay, but we take a segment of it, which is the A and the B. Okay, since this is an example and I want it to be general, so I don't put a value for it. Okay, so we put the first point as x1, y1, the second point b x2, y2. So from here, okay, as you know, to know the gradient, we take the horizontal, sorry, the vertical distance, okay, divide by the horizontal distance. Okay, so that means vertical distance will be the y coordinates. Okay, so you see y2, y1. Okay, so I take y2 minus y1, okay, divide with the x2, x1 minus x1. This is the horizontal distance. So gradient is given, okay, by the formula, okay, the distance of the vertical distance divide with the horizontal distance. Okay, this one we have learned. Okay, we know this. Okay, the gradient is actually the vertical distance. Okay, sorry, the vertical distance divided by horizontal distance. Now another thing that we sometimes not relate it with, okay, sometimes we forgot. Okay, so when you see the gradient like the vertical over the horizontal, so actually if I put the angle here, all right, theta, and then if I have okay, what is important here is the 90 degree, yeah, so the 90 degree here, so this will make a right angle triangle. So what we can say about right angle triangle is, okay, the right angle triangle is I can actually use the trigonometry formula. So what is trigonometry formula? We have sine, cos, tangent. So if you still remember the trigonometry formula, all right, it's actually sine equals to opposite over hypotenuse. Okay, cos adjacent over hypotenuse. How about tangent? Tangent is opposite, so opposite over adjacent. So opposite over adjacent is actually similar to the vertical distance divided by horizontal distance. So we can summarize that the gradient is actually equals to tangent theta. Okay, so that is how we can calculate gradient. Okay, Now, as for the angle, okay, sorry, not the angle, the line, okay. If we have parallel line, okay, parallel line means L1. Okay, I show here, yeah, L1, L2, and it will never match. Okay, no matter how long I draw, I will not never match. Okay, they will never match. So when I have parallel line, okay, the angle that I can form between the line with the x-axis, okay, is the same. Okay, if they are not the same, they will meet somehow. Okay, but if they are the same, okay, they will never meet. Okay, so based on this understanding and the logic of it, okay, if I can use the gradient is tangent theta, right? So since the theta is the same, all right, see, since the theta is the same, that means the tangent value will be the same. So when you have two lines where the gradient is the same, okay, meaning the line is parallel. Okay, so this one you have to understand, or we have to use it often, okay, to solve the problem. M1 equals to M2 when the lines are parallel. Okay, so let us see the next one. Okay, for gradient, okay, for the two gradient for the two line which is perpendicular to each other. Okay, so just now we have learned parallel, so now we go for perpendicular. So again, I have for example here L1 and L2. So L1 is 90 degrees to L2. So the angle that we see is between the x-axis and also the line. So this is theta 1. Okay, theta 1 is the angle between x and also L1. Okay, now if the two line is 90 degree, okay, perpendicular to each other, so what we can conclude with this angle? Okay, theta 2. Okay, okay, what we can do? Okay, do you remember? Okay, theta 2 is actually equals to 90. This is the angle 90 plus with the 90 degree plus with the theta 1. From here plus here will equals to theta 2. Okay, so this is a formula that you will have learned. Okay, the exterior angle. So exterior angle is actually the interior angle or the opposite. The remote means the opposite interior angle. Add up, you will get your opposite angle. Okay, the exterior angle, sorry. Exterior angle equals to opposite angle. Add up. Okay, so why I need this? Okay, so based on the gradient again, okay, we will use tangent, right? So to prove they are 90 degrees. Okay, what happens when they are 90 degrees? So this is 90 degrees, so this 90 plus theta 1 equals to the outside angle. Okay, so theta 2 will be, okay, theta 2 will be, tangent theta 2 will be tangent 90 degree over plus theta 1. Okay, so what we can see, next one, okay, yes, this one. Okay, tangent theta 1 equals to AC divided by BC. Okay, AC divided by BC. Okay, so this is 90 degree tangent. Okay, opposite over adjacent. Okay, tangent theta 1 equals to opposite, AC is opposite, BC is adjacent. Then if I shift over, okay, BC over AC, okay, BC over AC, BC over AC, okay, it will become 1 over theta 1. Okay, means if theta 2, okay, this one is a bit on angle. So when we have theta 2 over here, it's actually negative sign of, if you do the triangle, okay, the triangle, you will get negative over BC over AC. Okay, this is the trigger formula. Okay, the trigger formula that you have, actually we will learn this in chapter 5. Okay, chapter 5. Okay, that one, not chapter 5. Okay, trigonometry, you will learn it from 5. Okay, you will learn it in during your form 5. Okay, how to change the angle into the exterior angle. So from here, tangent 90 plus theta 1 equals to 1 over tangent theta 1. Okay, so this is the formula. So what we can say about it, okay, after that you can do cross multiplication. So tangent theta 1 multiply with tangent theta 2 equals to negative 1. So it means that if I have angle, gradient for the line L1 multiply with the gradient for L2, okay, If I get -1, it means that the line, the both of the line is perpendicular. Okay, so the line is perpendicular when the gradient multiplied together equals to -1. So as similarly, this one is important for the next, to solve your mathematical problem. Okay, later on. Okay, so let us see example 5 from your textbook. Okay, so how to use the concept of parallel and perpendiculars. Okay, in your to solve your problem in the mathematical problem. Okay, first thing we will see here. Okay, so this question says that the lines, there are two lines here, so one line, two line, and these two lines are parallel. So when we see parallel, first thing you must know that this thing, okay, this must come, this information must come to your mind. Okay, that means you have to find gradient. Okay, whenever parallel or perpendicular, the first thing you must know or come to your brain or your mind is the gradient. So let us see. So what happens when it's parallel? So gradient is the same. So how to get gradient from the equation? Okay, so we have learned this. Okay, previously. Okay, so now this is the line. Okay, this is the line. Okay, then you have to what we call this one is gradient form. So we can change into gradient form. We have to write the equation into gradient form. Okay, this is just equation. Okay, so how to change to gradient form? So the first thing you put the y as subject. Okay, y as subject. So you shift. Okay, can so just shift over the negative, the positive 6 become -6. So after that you divide by 9. Okay, make the y as the subject. Okay, so from here remember the general form for gradient. Okay, the gradient form is y equals to mx plus c. So m is the gradient. So if we compare like this, so m will be -2 over 3. Okay, then c will be the y-intercept lah. Okay, so now the gradient for the first line, okay, is -2 over 3. So we memorize this. We just take note of this first. Okay, then we just go for the second line. Okay, so the second line equation is this. Okay, this is actually a intercept form. Okay, if you memorize the form, okay, this is the one. Okay, last time we have learned the gradient form, intercept form, and general form. So in intercept form, the gradient is taken. Okay, we can get the gradient by taking the constant of the, make it into a ratio first, and then it equals to 1. You see, similar already. So what I can do for the gradient is the gradient will be negative b over a. So -2. Okay, sorry, x. This one is y. X over a, and then y over b. Okay, so this one there is something wrong with the textbook. Okay, just correct it. Okay, x over a, y over b. So y over b. So the formula says that for the gradient it will be negative b over a. So what is b? 2. So we write 2. What is a? 3. So we write 3. Make sure when you use the intercept form, all the sign here is same. Okay, the plus, the 1 without negative. Okay, then only you can do straight. Okay, if you do not remember this, can or not? Can. Okay, you just change this. Okay, multiply by 6. Okay, multiply by 6, you will get back something like this. Okay, then you do into gradient form. Easier, I think. Okay, you don't need to memorize anything. Just y equals to mx over plus c. Okay, so now m1 is also -2 over 3. Remember just now? So since the m1 and the m2 is the same, so what we can conclude is the two line parallel? Yes. Okay, because they have the same gradient, so they are parallel. So let us see B. So B is also parallel. Okay. So when it's parallel, so please, this must come into the mind. Okay. M1 equals to M2. So parallel. So parallel means the straight line is parallel to this. So okay, I can actually find the value of K. Okay, how? Okay, so first thing, yes, again change to gradient form. Okay, change to gradient form. Yes. Y equals to mx plus c. So this one just shift over on it. Okay. Then the second equation also you change to gradient form. So this is the m. Okay. This is also the m. So since they are parallel, that means this should equals to this. Okay? So they are parallel. So they are equal. So you can just get your K value. Okay? So multiply and divide and simplify lah. Okay? So this is for parallel. Okay, next one we will see how it is a perpendicular. Okay? What happens if the line is perpendicular? Okay, now if the two lines are perpendicular, okay, see here. Okay, now the line is perpendicular, so I have two lines. So again, perpendicular, please, m1 multiplied by m2 negative 1. This one we have shown just now. Okay, so first thing, change to gradient form. Okay, so how to change to gradient form? Yeah, shift over, make sure the y is only have 1 as the coefficient, and the second example, second equation also same thing, make sure the y is also a coefficient of 1. Okay, so mx plus c. Okay, so since they are perpendicular, so if they multiply, if I can show that the two number here I multiply, I can get negative 1, means they are perpendicular. So what I do, I take this gradient, okay, alright, then I multiply. So m1 multiply by m2, so multiply this one. Okay, so when I multiply, we will get 3 multiplied by negative 1 over 3, you have negative 1. Okay, so when you get negative 1, so it shows that this two line is actually perpendicular. Okay, now, so we have to answer the question. Okay, does the straight line are perpendicular to each other? So next question, you will see the two straight lines. Okay, sorry, the vertex of the triangle. So now we have triangle KABC, such as K is a constant. So the ABC have these coordinates. Okay, 1, 2, 3. Okay, so find the value if the angle ABC. Do you know where is the angle? So what we can do is we draw out. Okay, so again you need this this info. Okay, so we draw out ABC. Okay, it's better to sketch more or less the correct one. Okay, 0, negative 1, 2, 1, and then C is here. So you just make it into triangle. And then where is the 90 degrees? So 90 degrees is at angle ABC. Angle ABC. So over here. Okay, so right angle, triangle. So what we can say? That means this gradient BC, okay, multiply with the gradient of AB, it should equals to negative 1. Okay, because they say it is 90 degree at this point. So there are two lines at this point. So this point, the gradient you multiply, you should get the negative 1. Okay, so then you remember how to find gradient? This is the formula. Okay, this is the formula. M equals to y2 minus y1, x2 minus s1. Okay, this is the formula to find gradient. So same, do you have y2, y1? Yes. Yeah, x2, x1. Okay, so you just use accordingly. Yeah, just don't use the formula. Just simply use. Okay, please make sure. Okay, this is y2. So now the y2 is here. This is y2. If this is y2, where is the x2? This is x2, x2 and y2 just a symbol represent the point, okay, at the same place. So y2, okay, x2, you see, is 2. Okay, then y1 minus y2 minus y1, so y1 is here. Okay, I'm using the this one is y1. Okay, y1, okay, x1. Very hard to write using this, Okay, y1, x1. Okay, now x1, y1, so negative 5 is y1, 0 is x1. Okay, then multiply with another gradient. The another gradient, this one is gradient for AB, MAB. Okay, MAB. So this one is M, gradient for BC. So it's here. Okay, here. Okay, MBC, MAB. Okay, so multiply, we should get -1. So after that, we simplify, you get your -4. So your value of k is 4. Okay, sorry, not negative. Okay, so after that, okay, actually this subtopic is just parallel and perpendicular, not difficult. So you finish 7.4 and 7.5, the self-practice. After that, you do your intensive practice 7.2. Okay, so till we meet again. Alright, so all the best and bye. Okay.